Okay, so the next video, that is 17, okay, video 17, no test, okay, the last video for this chapter, class 10 science, chapter 2, acids, bases and salts. This conclude the portion for chapter 2, okay. Now go to 16, textbook. Fresh milk has a pH of around 6, okay, fresh milk, keep that in mind. So that means the pH of fresh milk that you produce from the cow is acidic, because anything below 7 is acidic. How do you think the pH will change as it turns into curd? Now, as you keep the milk over time, over a long period there, we know that it turned to curd, and curd is that sar, tinga, right? Not like the fresh milk. Explain your answer. Okay? Let us read the question. There on your textbook, write question number 16. Textbook, page 36. Near that you write tuition note. Page, yes, tuition note, page 79. Okay? 79. Now go to your page 79. Write like this on your textbook near this question. And go to page 79 of your tuition note. We can just read through it, I think. Let me read. Answer. As fresh milk, page 79. You're there, right? Okay, good. As fresh milk turns into curd, its pH will change even below 6. Fresh milk pH is 6. We know that just now from the question. As it turns to curd, it will be below 6 also. Why? Very simple, because you see, if you drink the fresh milk, the taste is a particular taste. But curd is much more tenga, much more sour. Means much more tenga means it will be more acidic. Means the pH will be even lesser than 6, right? That's common sense. Now the explanation you give like this in exam, second paragraph. This is so because as fresh milk turns into curd, this is the technical reason. Why? As the milk turns to curd, why does it become more tenga or more sour? Because the curd, as it turns to curd, more lactic acid is produced. That's why it is becoming curd. Lactic acid is sour, tinga, is released. Every acid is sour. In fact, we learned that from the first definition of acids as we started the chapter, right? Making the curd sour and more acidic than fresh milk. The reason is the pH will go below as milk pH 6, fresh milk pH 6 turns to curd. The pH will even go below 6 because more lactic acid is produced, causing it to be more acidic. In other words, more sour, right? So that's very easy. Now let us go to 17a, textbook. A milkman adds a very small amount of baking soda to the fresh milk. Usually milkmen do this. Baking soda means sodium bicarbonate, NaHCO3. Always he add a little bit. Why? Why does, number A, why does he shift the pH of the fresh milk from 6 to slightly alkaline by doing this? Because NaHCO3, baking soda is basic. So if he add the base, means the pH of the fresh milk will go above 6. Why is he trying to raise above 6? Right? So near that question number, you write tuition note, page 79, 80. Question number 17, textbook, page 36, tuition note, page 79 and 80 will find this. So write like this on your textbook, and then let us go to page 79, 80. Okay, let me go to page 80 now. 79 is the question only. A, B. Okay, why does this milk, okay, number A, page 80, why does he shift the pH of the fresh milk from 6 to slightly alkaline by doing what? By putting this baking soda, NaHCO3. Number B, why does this milk take a longer time to set as curd? In other words, when he add the baking soda, the milk takes longer time to change to curd? Why this happen? Number A, let us answer first. He shift the pH of the fresh milk from 6 to slightly alkaline by adding baking soda. Why? To delay the turning of fresh milk into curd. Because when you add the baking soda, which is basic, the pH will go above 6, 7 maybe. So for the milk to turn from 7, now if it go below 6, it becomes curd, right? 6 is fresh milk, look here. So when you add baking soda, in the milk, he causes it to go above 6. Now when it go below 6, let us say 5, pH 5, this is curd. This is fresh milk. Now when he put baking soda, it goes 7, means for the milk to travel from pH 7 to 5 to become curd, it will take a longer period, so the milk will not get spoiled. That's why he do that. Okay. Next, B. Let me read. Why does this milk take a longer time to set? Just it takes a longer time. Why? Let us see. The baking, I already explained, but let us read through. The baking soda neutralizes the acid in the fresh milk and shifts the pH from 6 to slightly alkaline, means basic. That means slightly higher than 7, above 7. So when he does that, 7.5 like that, 7 is neutral, so he shift baking soda added means the pH will go above 7 slightly, right? Because alkaline means pH should be above 7. Therefore, this milk takes a longer time to set. I told you, to travel from 7.5 to drop to 5, which is curd, will take longer than the fresh milk. If he didn't add, then the fresh milk would have turned. So to turn from here to here is, let us say, 5 hours or 10 hours. Then if he add the baking soda, to turn from here to here is another 10 hours. So now together 20 hours is the milk to which is added baking soda will take double the time to change to curd, so the milk will remain unspoiled for longer period and he can sell it, right? So that is it. And the last question there, question number 18. So question number 18, this is on your textbook, page 36. And this will cover almost all the questions on your chapter, okay? Inside textbook, outside textbook, at the back of textbook, everything will be almost virtually covered properly. If you go through this, you are prepared, right? Now let me read the question on the text. 18. Plaster of Paris should be stored in a moisture-proof container. Explain why. Tuition note, page 80. Write that on your textbook and go to tuition note, page 80. Okay, let me read this one on your tuition note. Are you on tuition note, page 80? Everyone? Okay, good. Now look there attentively. Just listen carefully to this. Plaster of Paris should be stored in a moisture-proof container. That means plaster of Paris, the white powder, should always be in a tight container, away from the outside moisture. Why? Because we know this. When exposed to moisture, means water, plaster of Paris absorbs the water and a hard mass of gypsum is formed. Therefore, it should be stored in moisture-proof container. So we know that when the doctor is going to set it on the broken bone, he will mix the white powder with water, then it becomes a hard mass called gypsum. Now, we don't want that to happen before being used. So when in storage, it should be tight. Otherwise, it will combine with water. We saw this in question 96. You go read right now and read question number 96, and you will understand it so clearly. So this concludes the video for, I think video 17 is the last one. Question 16, 17, 18 for the entire chapter 3, acids, bases and salts. I hope you have learned you have learned something from this chapter, right? Okay.